We're back. Now we're going to learn method number 2 on how to change a fraction into its equivalent decimal. The last thing we did, we saw very easy fractions, fractions that had a tenth already, or 100, or 1,000. Now we're going to use everything we've learned so far about changing one fraction into an equivalent fraction, okay? Only we're going to take a fraction, change it into an equivalent fraction that works better for us. Here's one example. 4/5. Our job is to take 4/5, change it to its decimal equivalence. Well, it looks like we have a problem. When you think back on the last method that we learned, there's no tenth here. So this fraction doesn't make it easy for us. But you know what we can do? We can change this fraction to a fraction that is equivalent to, that has a tenth, 100, or 1,000 in the denominator. We've done this before. We know how to fill in the blank. We know how to figure out the process, the method. How could I change this 5 to a 10? If you're thinking times 2, you're right. Since I did times 2 in the denominator, what might I want to do in the numerator? If you're thinking multiply by 2 up here as well, you are correct. 4 times 2 would be 8. So now we've got one fraction here. Our job was to take this fraction and change it to a decimal. We took a small little detour. We change this fraction, 4/5, into a fraction that doesn't change the value, just looks different. Now, isn't this an easier fraction to change into a decimal? Now it has the tenth in it, just like we like. 8 tenths should look just like 8 in the tenths place, 8 tenths. Okay, we're going to do a couple more of those that are just like that. Actually, we're going to do a few more of those because there's a couple of ways you can do it. We multiply. You can also find equivalent fractions by dividing. We learned that all this week and all last week. Okay, so we're going to try a few of those. The next example is 8/20. Our job is to take 8/20 and change this fraction into its decimal equivalence. Well, 20th doesn't fall anywhere on the place value chart. There's a tenth, there's a hundredths, and there's a thousandths. So I'd like to change this fraction to an equivalent fraction that has a tenth, a hundred, or 1,000 in the denominator. I can change this one a couple of ways. I could change it to 100. Because I know if I count by 20, 40, 60, 80, 100, I know that 100 is a multiple of 20. So if you're thinking, how do you get from 20 to 100? If you're thinking multiply by 5, you're correct. And since I multiplied by 5 in the denominator, I always want to multiply by 5 in the numerator. 5 times 8 is 40. The proper way to say this fraction is 40 hundredths. So when I write my decimal equivalent, I know the hundredths place has to be 2 places behind the decimal. 40 hundredths. 8/20 is equivalent to 40 hundredths is equivalent to 40 hundredths. All right, we're going to do a couple more of these. Here's another example, and we may see one like this on some of the work that we're getting ready to do. 4/25. And I know you're thinking, okay, there's no way to make a 25th into a 10th. There's no way to make a 25th into 100. But there is. Got to think. and fractions work just like money. So 25th would be like 25 cents, a quarter. How many quarters does it take to make 100 or $1? We can turn this into 100. Remember, these are the fractions that we like. We don't like these. We like these, the ones with the tenth, the hundreds, or the thousands at the bottom, because they're easy to change. If you see a fraction and it's not easy to change, then you make it into a fraction that's easy to change. How would I move from 25 to 100? What's the process? If you're thinking times 4, you're absolutely right. And since I multiplied times 4 here, I'm going to multiply times 4 here. 4 times 4 is 16 hundredths. I can't stop here because I still don't have my decimal. This fraction just makes it easier for me to find my decimal. 16 hundredths, when you say that properly out loud, looks just like 16 hundredths as a decimal. So our original fraction, 4/25, is equivalent to 16 hundredths. Okay, I'm going to do a couple more of these. Only, I'm going to use a fraction that we've already done, just to show you what the division part of that looks like. A while ago, we did 8/20. We changed our 20th to hundredths. This time, I don't want to do that. I want to change my 20th to tenths. Just to show you it can work either way. As long as you change the fraction to an equivalent fraction with a 10, a 100, or 1,000, you've got your choice. How would I move from 20 to 10? If you're thinking divide by 2, you're absolutely right, which would mean I also need to divide by 2 in the numerator. 8 divided by 2 is 4. 4/10, when I say it properly out loud, should look and sound just like 4/10 in a decimal. So 8/20 is equal to 4/10 as a decimal. When we did it just a second ago, we found out that 8/20 is also equal to 40 hundredths. These two decimal numbers are the exact same thing. I bet a lot of y'all remember that from last year being in 5th grade. Okay, we'll do one more example, and then we'll move on. Okay, our last and final example is 30 for 200. I know that's a very big fraction, very big numbers, okay? But remember, all you have to do is focus on changing this fraction. If you don't like this fraction, change it. Change it to something it's equivalent to that has a 10th, a 100, or 1,000. Well, I'm thinking the closest thing to 200 would be 100. I can make this fraction into a hundredths. How do I move from 200 to 100? If you've got $200, what operation do you need to do to end up with $100? You probably need to split your $200 with someone or divide it by 2. And since I divided by 2 in the denominator, I also need to divide by 2 in the numerator. 30 divided by 2 is 15. We can't stop there. 15 hundredths should look and sound just like 15 hundredths of the decimal. So we've done 6 different examples on how to change that. Please make sure you're taking notes just so that we remember. We should be really good at doing this because we've done that for the past week. We just added an extra step. That was method 2. All right. We are going to move on. We're going to take a quick break. And then we're going to move on to method 3. Method 3 is much more involved. It's got some steps. It has some stuff that y'all don't really like from 5th grade, like the long division, okay? But it's a skill we're going to have to practice. It'll be okay. We're going to get comfortable with it. But when we come back from our break, we're going to show you method 3.